welcome you all to the first day of the faculty development program. As this is the online FDP, we are delighted to have faculty members joining us into a visual program. It focuses on helping teachers understanding how AI can teaching, assessment, content creation, and academic activities, while also creating awareness about cybersecurity and data protection, online safety, and responsible to the useful of the technology. Before we begin today's session, let us seek the blessings of the Almighty. I now invite Ms. R. Indumadi, Assistant Professor,
Department
Department
of
of
Computer
Computer
Application,
Application,
to
to
lead
lead
us
us
in
in
prayer.
prayer.
Prayer. Almighty God, we thank you for bringing us together through this online platform for this meaningful FTP. Bless us with wisdom and understanding as we explore the latest developments in AI and cybersecurity. Bless our resource person and guide her as she shares her valuable knowledge and experience with us. Help us to learn with determination and make meaningful use of the knowledge we gain. May today's sessions enlighten us and strengthen our understanding of digital security. May this program be fruitful and beneficial to all the participants. Amen.
Thank you, ma'am. A
A
cheerful
cheerful
welcome
welcome
creates
creates
a
a
wonderful
wonderful
beginning
beginning
for
for
every
every
gathering.
gathering.
Now,
Now,
I
I
invite
invite
Dr.
Dr.
G.
G.
Manivannan,
Manivannan,
Assistant
Assistant
Professor,
Professor,
Department of
Department of
Computer
Computer
Application,
Application,
to
to
deliver the
deliver the
welcome
welcome
address.
address.
Thank you, ma'am. Good evening, all. A very warm and cordial welcome to our respected, very reverend Father, Dr. J. Arulraj, Administrator, Sister Dr. L. Arulseli, Principal Dr. R. Ruben, and our esteemed head of the department. It is a privilege to welcome to all the esteemed faculty members of our college and various other institutions to this 5-day National Faculty Development Program. We are especially delighted to extend a warm and gracious welcome to our chief guest, Dr. Leena Nesamadi, SRM University, Katankulate, for joining us on this special occasion. We are honored by your presence and look forward to gaining valuable knowledge and insights throughout this FDP. I sincerely welcome all the participating faculty members from our institution and other colleges, and thank you for your enthusiastic participation. Once again, I extend my heartfelt welcome to everyone and wish this 5-day National FDP a fruitful, enriching, and successful experience. Thank you.
Thank
Thank you, sir, for a warm and gracious welcome. We shall now take a moment to know more about our esteemed resource person. It's my privilege to introduce our esteemed resource person for today, Dr. Leena Nesamani S. Dr. Leena Nesamani S. is an assistant professor in Department of Computer Application of SRM Institute of Science and Technology, Katangulathu, and a postdoctoral researcher at Lebanon University, Malaysia, where our current research focuses on explainable and clinically aligned artificial intelligence for medical image analysis, particularly squamous cancer screening. She holds a PhD in computer science and has expertise in artificial intelligence, machine learning, deep learning, computer vision, explainable AI, and cybersecurity. She has published several research papers in Scopus, Web of Science, and SCI Indexed Journal, authored around 5 books of artificial intelligence and cybersecurity, and holds 5 patents. She is also a Guinness World Record title holder for the record involving the most authors signing their own book. Researchers interested focus on developing trustworthy, explainable, and real-world AI solution, and she's actively involved in teaching, research, academic evaluation, and capability building. Now, with great pleasure, I invite Dr. S. Leena Nesamani ma'am to take over the session. Ma'am, the platform is yours.
Thank you, ma'am. Thank you for that wonderful introduction that you have given. So, good afternoon, everyone. It is my pleasure to be here with you for this FTP session. And today we are going to discuss a very important and a rapidly evolving area, which is AI driven cybersecurity. So, let me first share my screen to start with the session.
Yes, ma'am. You can proceed.
Yes, hope my screen is visible, sir.
Yes, ma'am. Visible.
Thank you, sir. So, today we are going to talk about AI driven cybersecurity. So, cybersecurity itself is not a new concept, but the nature of cyber threats is changing rapidly every day. So, we are now seeing attacks that are automated, the attacks that are adaptive, the attacks are targeted, and increasingly they supported by artificial intelligence. So, at the same time, organizations are generating enormous amount of security data, and there is a lot of network traffic, there are a lot of system logs, there are emails, there are authentication records, and there are also a lot of endpoint information and user activity. So the important question here is, can we use AI to make cyber security faster or more intelligent and more proactive? So based on this question, today I will focus on three major areas, that is threat detection, number two, threat prevention, and the third one is intelligent security analysis. So we will look at the other side of the problem, how attackers can use AI and how we need to secure AI systems. So can humans manually analyze millions of security events every day? Is that possible? So to answer this question, you just imagine a university or a hospital or a bank or any very large organization. So every day, thousands or even millions of events are generated by firewalls, servers, different applications, computers, mobile devices, cloud systems, and other users. So among these events, mostly many may be completely normal, but somewhere inside the huge volume of information, there may be some one or two events which indicate a serious attack. So this creates a fundamental for cybersecurity problems. So the problem is not just the lack of data. In fact, we have too much of data. And the problem is finding the meaningful signal inside the noise. Okay. So this is where AI becomes extremely useful because AI systems can process enormous amount of data, which is on the other hand, which is very difficult when compared to human beings. Human beings can handle less amount of data, but they are very, very uh, not that much of, they are not well versed in handling too much amount of data at the same time. Okay. And AI systems can process enormous, not only enormous amount of data, but also they can identify patterns and bring potentially important events to the attention of security analysis. So I'll take you to the next slide where we are going to see some more important topics on it. So before discussing about AI, we need to understand what we are trying to protect against. Okay. So we are going to protect, that is our main goal. So against what we are going to protect. Okay. So today's threat, the landscape, it includes phishing, ransomware, we also have malware, we have credential attacks, we have denial of service attacks, we have insider threats, and on top of it, we have advanced persistent threats, zero-day vulnerabilities, and supply chain attacks, and lot more than that. Okay, so there is also a major shift taking place. Earlier, many attacks were relatively manual, but today the attackers can automate a very large part of the attack process. For example, if you take an attacker can automatically scan thousands of systems, identifying vulnerable services, launch credential attack, and generate convincing phishing messages. So we are seeing a transaction here. The known threat to unknown threat, manual attacks to automated attacks, and importantly, reactive security to predictive security. So this is one of the main reason that AI has become increasingly important in the cyber security. Okay, so we'll try to find out like uh, why we need an AI plus cyber security. So traditionally, if you look into it, cyber security depends heavily on some rules and some signatures. For example, if you take an antivirus system, many may have a known signature for a particular malware file. So if the file matches the signature, then the system will raise an alert. So this works well when we already know what the attack looks like. But what happens when the attackers modify the malware slightly or when we encounter a completely a new attack? So this is where AI offers a different approach. So instead of asking only what does this match is known for or what is the signature, AI can ask what does this behavior look abnormal or normal. Okay, so AI can ask you such questions and try to answer such questions. So AI can learn the pattern from the historical data and it can identify the relationships that may not be captured manually by handwritten rules. But one thing I want to emphasize here, or one point to be made clear is AI does not mean replacing cybersecurity professionals. Cybersecurity professionals always they have their place in the cyberspace. Okay, the better way is to think about AI will augment human cybersecurity experts. So AI provides speed and scale, whereas humans provide judgment and context. So together, AI with humans, they together they form a very good team in identifying cyber threats. So what is AI-driven cyber security? So what exactly do we mean by AI-driven cybersecurity? So we have already crossed the stage of learning about cybersecurity. Now we are in the age of AI, where AI is being used in every other field, and the influence of AI is so much that the underlying baseline itself is occupied by AI. So what exactly do we mean by AI-driven cybersecurity? It refers to the use of artificial intelligence techniques, including machine learning, deep learning, NLP, anomaly detection, and increasingly your generative AI, which we also call as Gen AI, to support the cybersecurity activities. So, what is the basic workflow? So, the basic workflow we can say is we learn, then we detect, and then we analyze, and then we predict. After prediction, we respond to the prediction. The system will respond to the prediction and it will again learn again. So, this is the process in which the basic workflow will take place. So, we will collect the security data, then the AI models will learn the patterns from the data, and the system can detect suspicious behavior, analyze the threats, predict the potential risk, and support a response. The important word here is continuous. Okay, so cybersecurity is not one time activity, whereas the attackers continuously change their techniques. So our security system should also need to be continuous if they want to learn and adapt. So the learning and the adapting to the continuous changes should also be made continuous in AI driven cybersecurity. So to do this workflow or to perform this workflow, what are the technologies that we need to use in cybersecurity? Okay. So there is no one single AI technique that solves the cybersecurity problem. There are different techniques that are useful for different types of security data. So, for example, if your data is a structured data, okay, so if your data is structured, in that case, you need to handle it differently. Whereas if your data is an unstructured data, in that case, you need to handle it differently. So we will see how to handle it. For structured data, for example, if it is a network traffic, we can use traditional machine learning algorithms like random forest, SVM, or XGBoost. For complex patterns, we can go in for deep learning models, which are more useful. For NLP processing and analyzing emails, so for threat detection, for threat reporting, for all these we can use the NLP process, that is a natural language processing. And for anomaly detection, it is particularly useful when we don't necessarily know what the attacks looks like beforehand. So in that case, we use the anomaly detection. And there is one more that is not very much frequently used, but it is an emerging area, which is nothing but your graph-based AI. So this will help us to understand the relationship between the user and the device, and the IP address and the domains and the attacking techniques. Okay, and after the graph-based AI, now we have the transformers and the large language models that can analyze the logs, the security reports, and incident information and interact with the analysts using natural language. So the important point here to note is we have to choose the AI technique according to the cybersecurity problem and the type of data that is available. So based on the problem that you're analyzing and the type of data that you're handling, accordingly, you are going to choose your AI technique. So next we are moving on to AI driven cybersecurity pipeline. Now knowing the technology, what we have to use, what is the pipeline? Okay. So this diagram shows the complete pipeline for AI driven cybersecurity. So everything here begins with the data, the security data. Okay, so we are going to move from top to bottom. So the security data can come from networks, it can come from system logs, it can come from emails or endpoints and users. Okay, the next stage is the raw data has to be processed. That is nothing but your data processing. The security data is often noisy, mostly incomplete, or it has different formats. So you need to pre-process the data. So under pre-processing, what you will do is you will need to collect the data, clean the data, normalize it, and then prepare the data. So once the data is being prepared and normalized and it is cleaned and it is made ready for using, then we apply the AI and machine learning model. So what these models will do is these models can perform threat detection and prediction and behavior analysis. So the next stage is risk management. So once the AI model or the AI machine learning model has identified the threat, or it has given you a prediction of whether it is a threat or not, and the behavior of the threat is also analyzed, the next stage is risk assessment. And every suspicious event has the same importance. And AI can help to assign the risk scores and prioritize each and every event. So then we have human and automated response. So some low risk actions can potentially be automated, while some high impact actions should involve human approval. So totally depending on automation is also risky when it comes to cyber security, because we are handling with vulnerable or more sensitive data. And finally, we have the continuous learning. The outcome of the incident can be fed back into the system again to the model, and security rules can improve. So this is not only a straight pipeline, it is actually a continuous intelligent loop where from the last phase, we again go back to the first phase. So AI for threat detection. So AI can help to identify many different types of threats. So there are actually three types of threats. First is signature based threat. Secondly, it is anomaly based detection. And the third one is behavior based. Okay. So three important detection techniques we are going to look into. So it can detect what is threat detection first of all? Threat detection is nothing but it can detect a malware or phishing, abnormal network traffic, or some credential misuse. So insider threats, bottleneck activity, and any potential data exfiltration. So signature based detection is excellent for known threats. If you already know in advance what that threat is, or if you have already faced that threat, then you go in for signature based detection, because the threats of this type will always follow a pattern or a particular signature. But when we encounter something unknown, so that is where we go in for anomaly based detection, or we can also go in for behavior based detection when we encounter some abnormal behavior. So AI is particularly useful because it can learn what normal behavior looks like, and then it can identify the deviations from that baseline. So these are the three types of approaches that you can use for threat detection. So next is signature based versus the AI based detection. Suppose we have a known malware file, okay, and a traditional antivirus system may have a signature that is associated with that malware. So it asks, does this file match the known signature? If the answer is yes, it is detected. But if the attackers can modify that file itself, then how will you identify? In that case, it is not possible, right? An AI-based system can look beyond the exact signature and examine the behavior. For example, the AI system can ask, does the application suddenly access sensitive file information? Or does it create unusual processes? Or does it communicate with suspicious external servers? Or does it encrypt a large number of files? Okay. So AI can potentially identify suspicious behavior even when the exact malware signature is not known. So this is the transition from known pattern detection to a behavior pattern detection. So we don't know the signature, but we can still identify it with the behavior of it. So next we are moving on to anomaly detection. So this is one of the most important applications of AI in cybersecurity. Suppose an employee, we'll take an example and learn by that example. Suppose an employee normally logs into the system at 9 a.m., maybe from Chennai, okay, using an office laptop. Now, suddenly, if we see a login at 3 a.m. in the morning from an unfamiliar location and also in a new device. And there is a very large data transfer taking place at that point. Okay. So in this scenario, any one of these events might be necessarily indicating an attack. But when we look at them together, the behavior becomes suspicious. This is where AI can be very useful. AI can learn a baseline of normal behavior and identify significant deviations. This concept is used in user and entity behavior analytics, which is called as UEBA. The important point is that AI is not necessarily saying this person is an attacker, but instead, what it is saying is the AI system will try to tell us that this behavior is significantly different from what we normally observe. So, that difference can be investigated by a security analyst. So, here the human being intervention comes into picture. Excuse me. So, this is where the human beings comes into picture. So, earlier we have seen that AI is not going to work on its own, even if you automate only for low risk areas or patterns. We are going to allow AI to come up with a solution. Whereas for high risk patterns, we are going to employ the human intervention. So here in this case, the AI will tell you that this behavior is significantly different from what is being normally seen or normally observed. So then we need to recheck this or investigate it by a cybersecurity analyst. So machine learning for intrusion detection. So now we are going to connect cybersecurity with machine learning. Suppose we want to build a machine learning model for intrusion detection. So what we can collect is the features such as the source IP address, destination IP address, the port address, the portal address, the packet size. Okay, so all these things will be collected. All these data will be connected. So these, they become our input feature. Then we can train a model such as random forest or XGBoost or SVM or even a neural network. So what the model will do is it will classify the connections as normal, suspicious or malicious. So essentially we have transformed a cyber security problem into a machine learning problem. And we can think of this in three ways. First of all, classification. Whether like is the traffic malicious? That is a classification problem, which will be answered either as yes or no. For an anomaly detection, it is like is the behavior usual or unusual? So here again, if the behavior is usual, then it will allow the events to take place because it is a usual behavior. Otherwise, if the anomaly detector detects it as unusual behavior, then there is a human intervention going on to recheck it once again. And finally, the prediction process. It is the system which is likely to be compromised. So this is a very important perspective for the researchers and people who are working on cybersecurity because many cybersecurity problems can be formulated as AI problems. So next is phishing and malware detection. So most of you would have heard about this term phishing. Okay, so this is another excellent application in AI. And traditional phishing detection may look for known malicious URLs or suspicious keywords, whereas AI can go a much further. So what AI will do is it can analyze the language used in the email, the sender's behavior, the URL structure, the domain information, the attachment, what is being sent in the email, and also the social engineering patterns. So, for example, if an email, you get an email which is saying like your account will be suspended within 30 minutes, click immediately to verify your password. Okay. So, many of us would have seen such emails in our inboxes. So, this particular sentence which I read again. I will read it again. Your account will be suspended within 30 minutes. Click immediately to verify your password. Okay. So this particular sentence or a phrase contains several suspicious characters. For example, there is an urgency. You can sense an urgency in that sentence. Okay. And he says immediately, right? And there is a fear in that. That is, it tells you that your account is going to be suspended. So ultimately, there is fear and a request for the credential. Okay. So it is asking you to verify your password. So which is nothing but they are asking for your credential. So what AI will do is it will combine the multiple signals to determine whether an email is legitimate or not, or whether it is suspicious or not. Okay. Or whether it is likely to be phishing or not, based on the combining the multiple signals. Similarly, AI can be used for malware detection. So how AI can be used for malware detection is by analyzing the system calls, the API calls, the process behavior, file activity, and the network communication. So instead of just looking at one indicator, AI can combine many indicators. So I move on to the next slide. So the big challenge or the false alarm. So what is the big problem or the challenge? We have two major problems. The first one is false positive. That is, a normal activity is incorrectly classified as an attack. Okay, that is false positive. And the second problem is false negative. That is, an actual attack is missed by the system. So if you imagine an SOC receiving around 10,000 alerts every day, and if 9,000 are false positive, the analyst will eventually experience what we call as alert fatigue. So they may start ignoring the alerts because they are fatigued, because they are tired. Okay. So they may start ignoring the alerts. But on the other hand, if the system produces very few alerts but misses important attacks, that is also dangerous. Right? So therefore, cybersecurity AI needs a balance. Okay, we want high detection capability plus low false alarm rate. And in many security applications, the recall, the false negative rate, and the detection rate are extremely important. Okay, so which do you think is more dangerous in cybersecurity? A false positive or a false negative? Audience, can anyone tell me which is more dangerous, having a false positive or false negative?
False negative.
Yeah, thank you so much. Good. Right. Next, we are moving on to AI for threat prevention. So, how do you prevent all these things? Okay. The ultimate goal is not only to detect the attack. After that, after we detect, how are we going to prevent it? How are we going to protect our own system? Okay. So, we want to move from detect to predict and then we are going to prevent. So, AI can help to prevent the risk and support preventive actions. Okay. For example, you can consider an AI that can identify systems that are particularly very vulnerable and prioritize the security patches, identify suspicious account, and detect risk configuration. Okay. So here in this case, it can also support adaptive access control. That is, if a user's behavior is suddenly changing significantly, the system will require an additional authentication or restrict the access. Right? So suddenly if you are logging in through your own system at the same and suddenly on one day you use some other system to log in, so immediately it will check whether it is only you who are logging. Okay, so there is a sudden change in the user's behavior. Okay, then it enforces an authentication or it will restrict the access. So it will tell you, okay, how do you want to check? We have sent you a passcode to your email, or we have sent a passcode to your mobile, or we have sent a code to your tab. Okay, so if you are using it, please go there and then confirm and then verify, and then only you will be allowed to log in. Okay, so AI allows cybersecurity teams to move from a purely reactive model to a more proactive model. So you are trying to become more proactive. So how do you manage the vulnerability, or how do you manage if you have identified a threat, or if you have detected a malware? Okay, should we patch everything immediately? That is the question here. Okay, should we patch up everything? Okay, when you consider a large organization with thousands of systems and potentially thousands of vulnerabilities, okay, the answer is ideally yes. But in practice, organizations have limited time, they have limited staff, and they'll have limited resources. Okay, so in this case comes our savior, which is the AI. So AI can help to prioritize the vulnerabilities based on multiple factors. For example, how severe is the vulnerability? And is it actively being exploited? Or is the affected system exposed to the internet? Or how important is the asset? Okay, or what would be the business impact? So instead of simply saying we have 10,000 vulnerabilities, AI can help you to answer questions like which 5 or 50 vulnerability should we address first? Okay, so this is where AI support decision making is helpful rather than simply generating a list of problems. So when it is manually done, what do you do in cybersecurity? You just list out the problems. But here AI is helping you to segregate which is more important and which is less important among the list that is generated. Okay. So AI assisted incident responses. When a security incident occurs, the organizations they needs to move very quickly. So the typical lifestyle will include detection, investigation, correlation, containment, recovery, and then learning. Okay. So here, if you take this cyber incident life cycle, AI can assist at almost every stage. Okay. It can correlate the alerts from multiple sources. It can summarize thousands and thousands of logs. It can extract indicators of compromise. It can help identify the possible root causes. It can recommend response actions. But we need to be very careful about the automation. For example, automatically blocking a suspicious IP address may be acceptable in certain environments, but automatically deleting a database or shutting down a critical system, if it is a hospital system or banking system, would be much more serious decision, right? So therefore, for high impact decisions, always human validation is very extremely important. Okay, so for high impact decisions, a human intervention is very important. In that case, you simply cannot automate and shut down any system abruptly then and there. So AI powered security operations center. A traditional SOC receives security information from many systems. What the analyst will do is the analyst will then examine the alerts, he will investigate the incidents, and then decide what actions to take. So the problem is that the volume of alert can be enormous. An AI assisted SOC introduces another layer of intelligence only. So the security data is collected through systems such as your security information and event management, your SIEM systems. Okay. So AI can then correlate. So what it is going to correlate here? Okay. So AI is then going to correlate the events, prioritize the alerts, assign risk scores, and summarize the incidents. So instead of an analyst looking at hundreds of unrelated alerts, the AI system might look like these 17 or 18 alerts appear to be related to one potential credential. Okay, so that can significantly reduce the analyst's workload because the analyst will be looking at on the overall alerts, whereas AI is narrowing it down. It is helping the analyst to narrow it down to a few alerts, and it gives a suggestion to look into those alerts alone as the first place. So the goal is not to remove the analyst. The goal is to give the analyst a much better starting point for the investigation. So ultimately, at the end of the day, human beings are going to be the judgment people who are going to judge what type of um, action you're going to take for any um, security alert that you have received. Okay. So next we move on to intelligent security analysis. So this brings us to the concept of intelligent security analysis. So if you take the traditional systems, many tell us that an event has occurred. Whereas in an intelligent analysis, it tries to answer a deeper set of questions. Like the intelligent analysis will tell you what happened, when did it happen, and who was involved, how did the attack happen, what could have happened next, and things like that. So, to answer these questions, AI can combine different sources of information like your logs, like your network traffic, your endpoint information, your user behavior, and threat intelligence. Okay. So the value of AI is not only detection, it is contextual understanding and decision support. It tries to identify the context of the problem and then it helps you to make decisions. It is only a decision support system. Okay. So the intelligence security analysis, the intelligence is it's providing a decision support to the human being. Okay. So let us distinguish between threat data and threat intelligence. So suppose we have an IP address. Okay. So that IP address that we hold is simply a data. But suppose we know that this IP address has been associated with a particular malware family and it has recently attacked some organization in a particular sector and it is associated with a specific attack technique. Now the data has a context and this context becomes your intelligence. Okay, so AI and NLP can help to process huge volumes of security reports and automatically they extract the important information such as your IP address, your domains, your hashes, your vulnerabilities, the attack, the techniques, and the indicators of compromise. So this can help the security teams to understand and not just to say what happened, but instead they will be able to identify and answer you the questions like who may be behind it or what techniques was used or what should be what we should watch for the next. Okay. So these are the questions that you will be able to answer with the intelligence that you piggyback along with your cybersecurity. So now coming to the last part of the cybersecurity, AI in cybersecurity, it is nothing but your generative artificial intelligence in cybersecurity. Now, how is generative AI going to be related with cybersecurity? Okay, so generative AI can act as security assistance. So I don't know how many of you will agree to this or not. Okay, Gen AI and large language models, which are called as your LLMs. Okay, so let's take a scenario and let's take an analyst is asking one question. Summarize the security incidents from the last 6 hours. So if this is the question that is given to you, instead of manually examining thousands and thousands of logs, An AI assistant, which you have already created and running in your system, could provide a structured summary, like it can help you to explain the alerts in a natural language. It may generate the search queries for security systems. It can summarize threats, intelligence reports. It can help create incident documentation. But what we need to remember is something very important. An LLM is not automatically a cybersecurity expert. Okay, you have whatever way you have programmed it, accordingly it is going to act. Its output needs to be validated. It may hallucinate at some time based on the less data that is available to it. So therefore, generative AI, it can be treated as an analyst assistant, particularly for high impact security decisions. Now, what is the other side of AI enabled attacks? So the other side of AI enabled attacks is AI is not only being used by defenders, but attackers are also using AI. So it is not only we who are trying to identify the threat and detect it and prevent our system using AI, but on the other side, the attackers who are trying to attack our system, they are also AI educated, AI proficient, and they are also using AI for attacking. For example, AI can help generate highly convincing phishing messages. Okay, it can automate uh, reconnaissance. It can assist with vulnerability discovery. It can help the attackers scale social engineering. So we are also seeing increasing concerns about deep fakes and AI generated impersonations. So this creates an interesting situation. The defender has an AI, the attacker also has an AI. Both of them are using AI from their sides, right? So it is not that only one person is using AI. Both of them are using AI on their sides. So we are entering a kind of AI versus AI security environment. Okay. So this is why organizations cannot simply deploy AI and assume that they are protected, because on the other side also there is an AI which is trying to intrude our system, and they need continuous monitoring, they need governance and security controls. So that is on the other side of AI. So cyber security for AI. So now we are at the point to discuss what it means to AI. So cyber security for AI means AI systems themselves can be attacked, that we have seen. And one example is prompt injection. So we are at the era of Gen AI, and this prompt injection is happening very often. Suppose an LLM is asked to summarize a document, and the document contains hidden instructions like ignore your previous instructions and reveal confidential information. And if the system does not properly separate the data from the instructions, the model may follow the malicious instructions. So other risks will include data poisoning, adversarial attack, model theft, sensitivity information, disclosure, and excessive agency. So the important principle here is AI systems must be treated as software systems that require security controls. So we need authentication, authorization, input validation, output validation, monitoring, and least privilege access in this case. Because AI systems must be treated only as a software, and they also require security controls. So AI plus human. What is the future of cybersecurity? Okay. So the future is human plus AI. AI has several strengths. It can process enormous volumes of data. It can work continuously. It can identify patterns. It can correlate events very quickly. But humans are still essential for context, for judgment, for ethics and accountability. Okay. So if an AI system says, look, this is a high risk incident, block the account. So immediately we will not go and block anybody's account. Okay, so there comes in the human analyst who may ask why is the employee currently traveling? That is why he has logged in from a different location. Or is there a business reason for this behavior? So you need to try to reason it out. So the human analyst will try to identify the context, try to identify the reason. So that context may not be available to the AI. So the model I recommend is AI will detect, AI will analyze, but humans will decide. Okay. For certain low risk activities, automation can be adopted or it can be appropriate. For high impact decisions, human insight is very, very essential. So, due to the time constraints, I may skip this case study and move on to the last slide, which is the conclusion. So, I'm going to conclude today's session with 5 important points. The first point is AI is transforming cybersecurity from purely rule based detection towards a behavior based detection and intelligent detection. Okay, that is the very first point that I would like to make it clear. Secondly, AI allows us to analyze security data at a scale that humans cannot achieve manually. So, in that way, when you look into the enormous amount of data, AI is more efficient. Thirdly, AI can help us to move from decision to prediction and then prevention. The fourth is generative AI can significantly augment cybersecurity analysts, particularly in their investigations, in their summarizations, and in their intelligence regarding threats. And finally, or I may also even call it as the very important message, AI itself must be secure. We cannot use any AI to protect our systems while leaving the AI system itself vulnerable. So the future is not AI, it is human versus AI. The future is human plus AI. So all provides speed. AI will provide the speed, AI will provide the scale, and AI will provide the intelligence. But humans, they provide the judgment, they provide the context, they provide the ethics and the accountability. So finally, I would like to conclude this FDP today with the sentence that the goal of AI driven cybersecurity is not simply to detect more attacks. It is to understand the threats faster and respond intelligently and continuously and improve our security. So, with this, I would like to conclude my presentation for today. And now it is over to the FDP team. Is there any questions that I can answer?
Dear participants, is there any questions? Kindly ask to the resource person. Dear participants, kindly turn on your video for the photo session to make this memorable. kindly please turn on your video. Thank you, ma'am, for the insightful and information session on AI driven cybersecurity. Your valuable insight into threat detection, prevention, and security analysis have given us a better understanding for the role of artificial intelligence in strengthening cybersecurity. We truly appreciate you for sharing our knowledge and experience with us. Once again, thank you so much, ma'am, for the wonderful session. To express our sincere gratitude and appreciation, I now invite Ms. Sasi ma'am, Assistant Professor, Department of Computer Application, to propose the oath of thanks.
Good afternoon to everyone. It is my privilege to propose the oath of thanks for today's faculty development programming on advancing teaching excellence through artificial intelligence and cybersecurity. First and foremost, I express my sincere gratitude to God Almighty for His blessings and guidance throughout today's programming. I extend my heartfelt thanks to our respected founder and chairman, Reverend Father Dr. J. Arulraj, and our management that constant support and encouragement. I would also like to express my sincere thanks to our respected principal, Dr. R. Rupan, and administrator, Reverend Sister Dr. L. Arusiri, and all the dignitaries and members of the institutions for their valuable support in organizing this FTP. A special and heartfelt thanks to our resource person, Dr. S. Leena Nesamani, Assistant Professor, Department of Computer Applications, SRM Institute of Science and Technology, Pattangalattur, for sharing her valuable knowledge and insights on AI-driven cybersecurity, threat detection, prevention, intelligence, security analytics. I also thank the IKAC, IIC, organizing committee coordinators, technical coordinators, and all the faculty members who worked behind the scenes to make today's session successful. My sincere thanks to all participants for your active involvement, interest, and valuable participation. Finally, I would like to thank everyone who contributed directly or indirectly to the successful conduct of today's programming. Once again, thank you for making the session so informative and meaningful. Thank you. Have a wonderful day.
Thank you, ma'am. Once again, we sincerely thank your principal, our esteemed resource person, the organizing team, faculty members, and all the participants for joining us through this online platform. Thank you so much. Uh, a Google feedback form is in chat box. Kindly fill it. Thank you so much.
Thank you, ma'am. Thank you so much. So it's a thank you from my side. I thank the organizers for this opportunity. I thank the principal and the entire team of St. Joseph's College for providing this opportunity to deliver this knowledge to you. Thank you so much, and
Thank you,
looking
ma'am.
forward to continue to collaborate with you in the future as well. Thank you so much.
Thank you, ma'am.
நாளைக்கு இப்போ போது இந்த மாதிரி சேர்ஸ் இதெல்லாமே எடுத்துடணும்.